Hi Math, I'm Andy. What happens when we need to take the square root of a number that is not a perfect square? Well, what we're going to do is we're going to estimate. We're just going to take a guess. We're going to get as close as we can to the actual answer without using a calculator to do it. So that's what we're going to figure out today. How do we take the square root of a non-perfect square? Well, we're just going to estimate. Now, let's just take a look at the perfect squares that we're familiar with up to the square root of 225. So our list of perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. These are all perfect squares. Now, we call them perfect squares because when we take the square root, we get an integer. So because square root is an integer, and an integer is a whole number. So again, take a look at those perfect squares. 1 is a perfect square because the square root of 1 is 1. 4 is a perfect square because the square root of 4 is 2. 9 is a perfect square because the square root of 9 is 3. 64 is a perfect square because the square root of 64 is 8. And again, really, squares and square roots, perfect squares, this really comes from the idea of a square. A square is the same length on all of its sides. So if I have a square that has an 8 on all of its sides, then the area of that square is 64, and 64 is that perfect square. So the list goes on from up to 15. The square root of 225, see 225 is in our list of perfect squares, is 15. And it goes on and on. There's perfect squares will go up for as however big we want because squares can come in any shape. So as you continue in your math courses, you're going to learn different ways to simplify square roots by factoring out perfect squares. But for now, what we're going to do is we're just going to practice how do you estimate the value of a perfect square. So let's take a look at the number 12. Number 12 is not on our list of perfect squares. So 12 is not a perfect square. So here's kind of what we want to do. Let's think about the square root of 12. And what we want to do is think of what perfect square numbers are close to 12. And so I see that 12 falls between 9 and 16. So 9 is a perfect square and 16 is a perfect square, and 12 is bigger than 9, but it's less than 16. So it's going to fall right in between there. Now I know that the square root of 9 is equal to 3, and I know that the square root of 16 is equal to 4. So if 12 is between 9 and 16, then the square root of 12 must be somewhere between 3 and 4. So it's going to be 3 point something. Now we want to round our values to the nearest tenths place, which is just one decimal place. So here's how I'm going to kind of estimate 3 point what. I'm going to look at where 12 falls on kind of like a number line between 9 and 16. So if I take a number line and I think of this being the number 9 and this being the number 16, I know that right in between there, halfway between 9 and 16, is 12.5. And I can do that by kind of counting, or I can take the average of the two numbers. 9 plus 16 divided by 2 is 12.5. So I know it's going to be exactly halfway. Now if I think about the square roots of these numbers, the square root of 9 is 3, and the square root of 16 is 4. And because I'm trying to get the tenths place, let's think of this as chopped up into tens. 2, 3, 4, 5, 6, 7, 8, 9. So if I kind of line up these number lines, I'm between 9 and 16, and I'm between 3 and 4. And so because 12.5 is halfway between 9 and 16, that would mean that 3.5 is going to be halfway between 3 and 4. And so I look at the number 12 and I see how close this is to 12.5. And so if 12 is this close to 12.5, then the square root of 12 is probably going to be around 3.5. So I'm going to estimate the square root of 12 as 3.5. That's going to be my guess. Now again, it's not a perfect exact value, it's just an estimation. Now we can actually check just by using technology. We'll use a calculator real quick. I want to know what is the square root of 12. And my calculator tells me that it's 3.4641011615. Now notice 3.46, look how close that is to 3.5, which was our guess. So let's kind of check out some more examples. The square root of 50, again, we look at the perfect squares that are close or in between. So looking at this list, I see 49 is below 50 and 64 is above 50. So I can say that the square root of 50 is between 49 and 64 because those are the closest values. Now I know the square root of 49 is equal to 7, and I know that the square root of 64 is equal to 8. So the square root of 50 must be somewhere between 49 and 64. Now think of how close 50 is to 49. 50 is just 1 away from 49. We just take 1 away. But 50 is 14 away from 64. So if I'm thinking of the decimal that is square root of 50, I know that it's not going to be 7.5 because it's way closer to the low end than the high end. And so what is the closest tenths place that I can get that isn't 7? Well, I'm going to guess it's 7.1 because it's that close. So again, you're looking at the closest perfect squares, and then you're looking at how far away it is, and you kind of just guess from there with your tenths place. Now I can just check my work. Let's take a look at the square root of 50, and we see that it's 7.07. Now 7.07, that would round to 7.1, so I'm really close. So again, we're going to take the perfect squares that surround our number and go from there. Let's look at 43. So checking my perfect squares, I see 36 and 49 are the surrounding perfect square numbers. So I know that 36 is less than 43 and 43 is less than 49. So my numbers are going to be in between 36 and 49. So if I take the square root of 36, the square root of 43, and the square root of 49, I get 6 and 7. So I know that the square root of 43 is somewhere between 36 and 49. Or I'm sorry, somewhere between 6 and 7. Now I'm going to check the distances. So I know the difference between 43 and 36 is 7. So I'm going to take away 7. And I know the distance between 43 and 49 is 6. And so I see that it's almost right there in the middle. It's really close to the middle between 6 and 7. And so I can say, well, because these are almost the same, I'll bet the square root of 43 is just about 6.5. And again, we'll just check just to see that we're on the right track. The square root of 43 is 6.55. So because it's 6.55, we could say that, well, maybe we could call it 6.6 because it is a little closer to 49 than it is close to 36. Again, it's not exactly halfway, but I think this is a really good answer. So again, the process here is we find the two perfect squares that are in between the number we want. We take the square root, and then we guess this number based on the closeness to the actual values. Let's take a look at the next one, the square root of 120. Looking up at my perfect squares, I see that 100 is a perfect square, and I see that 121 is a perfect square. So if the square root of 120, that's going to be between 100 and 121. So again, I take those perfect squares that surround the number that I want, and then I'm going to take the square root of those perfect squares. The square root of 100 is 10, and the square root of 121 is 11. And so I know that the square root of 120 is going to be somewhere between 10 and 11. Now let's check those differences. Between 100 and 20 is 20 jumps, and between 20 and 21 is 1 jump. And so clearly 120 is much closer to 121 than it is 100. And so what I would do is I would guess, well, since it's so close to 121, I'm going to guess that the answer is going to be very close to 11. Let's call it 10.9. So again, that same process, we're going to surround that number with the two perfect squares closest to it and figure that out. We'll just do two more just really quick. The square root of 21. Well, looking at my perfect squares, I see that 16 is in between 21 and 25 are the perfect square roots. The square root of 16 is 4. And so I'll take the square root, I get 4. The square root of 25 is 5. And so the square root of 21 must be somewhere between that. I see that 21 is 5 away from here and 4 away from here. So it's kind of in the middle, but it's a little closer to 25. So I might estimate it as 4.6. And finally, the square root of 75. Well, 75 is between 64 and 81. The square root of 64 is 8. The square root of 81 is 9. And so the square root of 75 must be somewhere between these two values. Now, let's take a look at that difference. 64 to 75, that's 6 plus 5, that's 11. And 75 to 81 is just 6. And so because it's closer to 81, it's not in the halfway point, but it's not super close to 81. Let's call this, how about, it's going to be 8.7, because it's kind of 3/4 of the way to 81. So that's how we're going to be estimating square roots when they are not perfect squares. Choose the perfect square that's closest, and then just kind of do your estimation from there.